So here is something wild. AI will get your authentication screen 90% done in about 90 seconds. Dead simple, right? You prompt it, you get a login form, maybe some OAuth buttons, maybe a password reset flow. Everything looks beautiful. But here's the thing. That last 10%, that's where you're going to spend 90% of your time. And it's the part that users actually feel and that security actually depends on. So today, I'm going to show you exactly what separates a demo auth screen from production-ready authentication. Let's dive right in. All right, so here's our plan today. So first, we're going to talk about what auth is. Second, we're actually going to get into how it works under the hood. Third, we're going to talk about this 90-90 rule. I'll show you exactly how AI scaffolds super fast, that easy 90%, but then we'll go deep on that brutal last 10% that most builders skip. And finally, I'll give you some core principles that you can kind of take away for getting your auth right so you can actually ship a product that people can trust. Let's get started. All right, so if you don't know me, my name is Sunny. I am a serial entrepreneur. I'm currently on my 4th venture. I used to be a senior engineer at Bloomberg and Shopify, and currently an adjunct professor at Columbia Business School where I teach technology. Listen, I have been building software for over 15 years, so I have pretty much made every mistake, so you don't have to. My goal for this video, and my goal for all of my videos, is to help you get your ideas out into the world. Let's get started. So first things first, what are we even talking about when we say auth? So when I say auth, I'm talking about this, your basic sign-in screen and your sign-up screen. So I would say both of these are part of the auth process. Simply put, authentication is just proving you are who you say you are. That's it. When you type in your email and password or you click sign in with Google, you're essentially authenticating. You're saying, hey, I'm me, let me in. So now why does this matter so much? Listen, authentication is your first impression before someone sees that killer feature or beautiful dashboard. They see your login screen. So if it feels sketchy, if it feels clunky, or if it's straight up broken, they're gone. They'll never see the rest of your app. So it's super, super important. So it's important to take it super seriously and make sure that it looks clean, professional, it's safe, and most importantly, it works. So now that we've talked high level as to what auth actually is, I want to kind of go under the hood a bit and really show you how it works. So we'll be covering 2 auth processes. The first one is email and password. The second one will be the Google auth. Let's start with email and password because it's a bit simpler. So what's actually happening under the hood? So first step, the user gets a screen like this, a login screen. When they type in their email and password, that gets inputted into your front end. That email and password gets sent to the back end. And then your back end will determine whether this is correct or not, whether we've validated or authenticated the credentials or not. In this case, we are going under the assumption that the email and password are correct. So in that event, the backend will then go ahead and send the approval message back to the front end, and bam, the user has been logged in, the user has been authenticated. So from here on out, they are able to access the logged in user experience. So fairly simple. There's definitely more complexities under the hood, but we want to keep it very simple at this level. This is enough information for you to know to build. Now let's move on to the other authentication methods. So as you can see, this is by far more complex than just a simple email and password. When you sign in with Google, now we're increasing complexity exponentially because now we have a third party involved here. So in this case, the user clicks that continue with Google button. And what happens is then the front end will redirect. It'll send the user to Google in the form of that consent screen that we've all seen and probably interfaced with many, many times. Then Google will directly ask approval and consent from the user, if this is an authorized case here, if this is an authorized application. Once Google gets that approval, they'll send a confirmation right here to the front end, while also sending an OK approval to the back end. And then finally, the back end will then send a final confirmation indicating that this user has been logged in, and it's just business as usual, just like we saw earlier. Now, it's interesting to note here that from a user's perspective, the continue with Google is actually so much simpler. But of course, when we're architecting very simple UIs and flows for an end user, it typically results in a very, very messy underlying system, which is kind of like what we're seeing here. Nevertheless, having a login with Google button, while technically more complex, definitely a winning strategy if you want more people to not only trust your product, but more people to sign up. Now, I want to also talk about this 90-90 rule that I've mentioned a couple of times. So again, the first 90% of building Auth can be generated very quickly, like in 90 seconds. So here's what I typically see with so many builders, and also even in my own process and my own experiences. You fire up these AI tools like Lovable or Bolt, and you instruct it to build your Auth flow for you, and you get a nice UI like this, and it pretty much works. Like, I can sign in and it works, I can sign up and it works, and everything seems to be working, and then you move on to the next feature. But here's the issue. Auth is more than just when things all work under perfect conditions. Building a robust Auth system is ensuring that things also work when we're not following the happy path. Things like when emails and passwords don't work. There's a whole variety of edge cases that we really want to capture here. So a core tenet of building a really solid Auth flow is error handling or validations. These are kind of used interchangeably. So error handling and validations is simply when you follow this unhappy path. Maybe you're submitting bad credentials, maybe your password is not fitting the required structure. There's various things that could result in a message that's being rendered on the screen. And what we want to do is we want to design our flow to not only render these messages, but render these messages in a clean, readable way, and also making sure that the content of these messages actually makes sense and is useful to the user. If a user is attempting to use your product, and again, this is the very first impression of your product, and they are unable to sign up, they will leave and you will never see them again. That's why it's so, so important to get these things right. Now, let's actually go even further and identify some of the actual edge cases that we really need to plan our Auth system around. This is not by no means an exhaustive list. So the magic link expired. So one authentication mechanism is what we call a magic link. So instead of actually putting in an email and password, a user just simply puts their email and then they get back a link to click, and then that will automatically sign them in. It's a very popular authentication mechanism. So one edge case that we would have to plan for is in the event that the link that gets sent ends up expiring, because those links are not issued in perpetuity. So we need not only a plan for it, but we need a actual correct, readable, intuitable message to the user so they understand what's happening. Also, many users have pop-up blockers. So when we do the login with Google, I mentioned earlier that it actually goes to a consent screen. That's a problem if you have a pop-up blocker, although many pop-up blockers will actually allow Google in particular, but many don't. So we need to figure out not only a plan for it, but an actual error message and just general messaging that is, again, actionable for the user. Something else, potentially maybe the user opts for a passwordless login on their phone, but now they're on their laptop. Again, we need to account for things like that, or This is very common that I've seen. If you're opting for a multi-factor authentication or just like a simple SMS verification with the code, sometimes these SMS codes get sent on a delay, especially if you're using an international network. So again, these are things that we have to account for within the authentication flow. Also, something else that I want to call out here is the risk of regression. Now, what do I even mean? So consider this scenario, which I'm sure we all have been in. You have a fully functioning system. You have a fully functioning auth flow. And you decide to add a major feature either through Lovable, Bolt, whatever AI tool you decide. And for some reason, the AI model goes rogue and starts messing with your perfectly functioning auth screens. And now the auth process no longer works. Maybe the feature works, but your auth process doesn't work. You've experienced a regression in your core functionality. And now people can't even log in or sign up. So it renders your entire product effectively unusable. This actually happens more than people realize, and it's a serious problem because if nobody can log in, you have no users. If someone unauthorized gets in, you have a security breach. So how do you prevent against this? You have to constantly be testing. Anytime you make a major change, test. And in fact, make a checklist of things that you have to check and test. Maybe that checklist includes creating an account, logging into that account, logging out. Make sure you do this every time you do a major update. Do not just ship and pray. You have to own your system. All right, so we've gone over a lot of the pitfalls. We've gone over why that last 10% is so excruciating. Now let's bring it all together. What are some core principles around auth that I can leave you with when building your auth flows? So number one, speed builds trust, clarity keeps it. So your login screen, of course, needs to load fast. It needs to respond immediately. That builds trust. But when something goes wrong, you need a crystal clear message. That's what keeps the user from totally bouncing. Very, very important. Something else to keep with you is you never want to leak truth in errors. This is a security principle. So you want to certainly show user safe messages like incorrect password, but log the precise reason on the server side. The other principle, you want to test all the unhappy paths. I mentioned this earlier. You know, it's very easy to test the login and log out, but you also want to test, well, what happens with bad credentials? What happens if this user has already had an account and is trying to create another account? You really want to make sure that you have a handle on all of the full universe of possibility when it comes to auth. And finally, you want to deploy with all-time paranoia. Every time you touch the auth code, every time that you make a major change, deploy it cautiously. You always want to test it. And more importantly, you always want to have a rollback plan. This isn't a place to just move fast and break things, especially when you have a product that is fully functioning with actual users and actual money coming in. Okay, so that is a wrap. Here's what we covered today. We talked about authentication, why it's so critical. It's your first impression, your first line of defense. We broke down how auth actually works. We covered an email password flow, and we covered the Google flow. So here's what I want you to do. I want you to actually look at your current auth implementation, or potentially the next one that you build, and audit it. Audit it against these principles that I've shared with you. Does it seem trustworthy? Are you handling errors properly? Are you testing unhappy paths? Because here's the bigger lesson. This pattern applies really to everything you build. AI can scaffold the obvious parts, but the details, the error states, the edge cases, that's where you can really add value beyond just the prompting. So if you have stuck around till the end of this video, thank you so much, and I will see you in the next video.